Now we're going to talk about acceleration. This is when the velocity is changing over a period of time. My friend works for Cessna, and this was the flight test aircraft that they were using last year in 2014. And it's finally gotten full certification, and this was my friend's where the company's debut of the airplane, and now it's being sold. And it took a lot of work for them to do that, and a lot of thought goes into the aerodynamics and the effects of air as it goes over the wing and over the whole body. And so understanding how velocity changes, especially in aerospace engineering, is very important. So acceleration is defined as the change in velocity over time, and it can be positive or negative depending on the direction. You can speed things up, you can slow things down, you can also turn. The way we calculate acceleration is the change in velocity over a period of time. And so with a constant acceleration, we know that it's getting faster or slower at the same rate, and that's what we'll be doing in our class. And acceleration has a sign. It's very important to understand that. So if the sign of the velocity and the sign of the acceleration are the same, an object speeds up. So in other words, if we had a car here with an initial velocity of 10 meters per second, let's say, and let's say the acceleration is positive 2 meters per second squared, that would mean that as the car goes, the velocity is this way, the acceleration is this way, it's going to get faster. And it turns out that acceleration, this tells you how much faster every second the car will get. So after 1 second, this car will be going 12. After another second, the car will be going 14. After another second, the car will be going 16, and so on. So it's going to get faster and faster and faster. Now the reverse is also true. If, let's say, our car here was going positive 16 meters per second, and acceleration was, let's say, negative 4 meters per second squared, after a second, this is how much the velocity will change. So the velocity will drop in this case because the acceleration is negative 4. So instead of 16, then it'll be going 12. After another second, it'll only be going 8. After another second, it'll only be going 4. And finally, after that next second, it'll come to a stop. And so when we look at how this works, demonstrate the motion of a particle that has zero initial velocity and positive acceleration, we would have a situation like this where a person's not moving and the acceleration is, let's say, positive, so the person's getting faster and faster and faster to the right. Another instance here where the particle has zero initial velocity, negative acceleration, so in this case, the person is not moving, and then they're going to get faster and faster and faster this way. Positive initial velocity, negative acceleration would be someone's going this way, and the acceleration is this way, they're going to be slowing down. Now, if a particle has a negative initial velocity and positive acceleration, that would be like somebody going this way, and the acceleration is this way. So even though the acceleration is positive, the person is going against that, and the person will actually slow down. So the sign, the direction of the acceleration, the direction of the velocity, we really have to pay attention to. Now let's go ahead and try a sample problem here. Let's say we have an airplane, 747, that will eventually take off at 180 miles per hour. It takes 30 seconds for that. We're going to find the average acceleration. We'll assume that the initial velocity is 0. So we know we're going to have to convert that 180 miles per hour into meters per second. So we can do that. Here's our conversion. So 1 mile is 1609 meters. 1 hour, 60 minutes. 1 minute, 60 seconds. And we can get our velocity there. We can get, and then again, we're looking for acceleration, and we have time as 30 seconds. And so with that information, we can figure out the acceleration. So our velocity comes out to be, final velocity is 80.45, initial velocity is starting from rest, and we get an acceleration of 2.68, and really positive 2.68 because the acceleration is this way as we define it from the positive x. Another helpful way to think of acceleration is how every second, how much does the velocity change? And so this is a really important idea. Let's say the car is starting from rest, and let's say the acceleration is positive 3 meters per second squared. So after the first second, how fast is it going? Well, if it's 3 meters per second squared, after 1 second it'll be going 3. Because every second, how much does the velocity change? And so now it's going 3. After the next second, the velocity is 6. After the next second, velocity is 9. And so on. So every second, this is how much the velocity changes. And that can be a really helpful idea to think through acceleration. So I want you to try this problem where we have a horse with an initial velocity. And you can draw just a real simple stick horse. Okay. And the initial velocity is 11 meters per second, positive. And it's accelerating at negative 1.81 meters per second squared. So the acceleration is this way. Velocity is this way, so we're slowing down. So go ahead and try this one and then enter in your answer. Okay, so when we solve for that, we're looking for how much time does it take to stop, and that's here. So we have the change in velocity over time. And when we cross multiply and solve for time, it would take 6.808 seconds if the horse is slowing down at that rate.